Day 126 notes. Using air pressure to make forecasts. Isobars are lines on a map that connect points with equal air pressures. So iso is the prefix that means the same. If I have a triangle with two sides that are the same length, we call that an isosceles triangle. It has the iso at the beginning. We have the word or the letters for bars here, and that refers to the barometer that measures air pressure. So this is the same barometer reading lines, so to speak. So what we do is we take all the different stations in the country. You can't really see the outline of the states very well here, but if you look carefully, you can see that it was just very, very faded. And these numbers represent the air pressure of lots of different weather stations around the country. We're going to connect the numbers that are the same. So here we have 1,016s. Here we have 1,020s. 1,024s. 1,016. 1,012s. And 1,008s. Label the center of high pressure with a capital H. Well, here's a small circle, that's a center, and it has 1,024. This circle has 1,008 pressure, so this is the higher pressure one. And this is the low pressure area. No other numbers lower than 108. There are no other numbers higher than 1,024. At high pressure, we have cool, heavy, dense, sinking air. This is not the conditions for clouds to form. Clouds do not form when air sinks. At high pressure, therefore, we have clear skies. At low pressure centers, we have light rising air. This is where clouds form. Clouds form when warm air rises high enough to cool down and to condense all of the moisture in it into snowflakes or raindrops. Okay, so by looking at the pressures, we can see here that in this part of the country, which is like Colorado and Nevada, that has high pressure, that's going to be clear skies. And over here we're going to say they're going to have cloudy skies because the low pressure of rising air is going to create clouds. So we can use maps like this to predict cloud cover. Now let's use pressure to predict wind. Air naturally wants to go toward low pressure systems, but the Earth's rotation makes the wind bend. And air naturally wants to go away from high pressure areas, but the Earth's rotation bends the winds. Winds always blow from high to low pressure. Think of a blown up balloon with high pressure on the inside. Air always goes out to the lower pressure room around it. The paths of winds are not straight lines due to the Coriolis effect. Let's look at these two situations in a profile. Let's say we have a tree here and we have the house here, okay, and then we have high pressure over here and we have low pressure on the left. Low pressure is because of air rising up and not hitting the ground so hard. High pressure because of cooler sinking air pushing down on the ground. But when the sinking air hits the ground, it's going to curl away and it's going to have to run along the ground. And so people along the ground are going to feel the air moving away from the high pressure system, and they're going to feel that as wind. Now remember, the H and L on maps are very confusing. People assume that since it's most important to them to look at temperature, they assume the H is for hot and L is for low temperature. That's not true. The H and L refer to pressures, not temperatures. So H's are places with low temperatures. L are places with high temperatures. Remember in our diagram here, the high pressure is because of cold sinking air. The low pressure L is because of warm or hot air rising. It's confusing, but you got to get used to that. Okay, so that predicts wind. So in our map here, we'd predict that the wind is going to go from the high pressure here to the low pressure. We're going to have stronger winds going from the west to the east. We have used this map now to predict the cloud cover at both places, and then the wind in this area as well. Okay, using pressure to predict precipitation. Air pressure is usually between 870 millibars and 1080. It can go a little bit higher and a little bit lower, but that's the typical range. So when the air pressure is below 1000, we have basically rising air, and we probably have a front passing through where the air is being lifted up, the warm air is rising up. And so that means we'll probably have some rain or snow depending upon the temperature. When air pressure is above 1000, we have sinking air. This is higher pressure. It's above 1000. Higher pressure because the sinking air pushing down on the ground. Sinking air doesn't form clouds well, so you're not going to have snow and rain when you don't have clouds forming. So we're going to have clear skies. So on our map here, we'd probably predict that there's going to be rainy weather or snowy weather over in this area of the country. I guess that's about Kentucky, Tennessee. And over here in Denver, Colorado, probably going to predict no rain, no snow. Okay, now let's review this map here, this chart that we've seen in previous days. What is the expected weather for Saturday, the 21st? Okay, here's Saturday the 21st, and we see that it's partly cloudy. That means that there is more blue sky than clouds. It says that right here. The high temperature is this number right there. It looks like 49. The low temperature is right there, 29. The chance of rain, that's going to be right here. Chance of precipitation, it's this zigzag line right here. And on Monday, there's this little spike here that's still in the Saturday. And that's going to be between 0 and 0 and 25. It's going to be about 10% here. I believe this is going to be on Sunday, these two little bumps. So we're looking over here, 10%. And the wind. It comes up to about 10 miles per hour, way over here. A student claims that higher temperatures increase air pressure. Do these graphs support that claim? So here we have the temperature, and here we have the pressure. Does it show that higher temperatures increase air pressure? Consider these two sections and see if you agree or not. And the answer is no, because here the temperature is going downhill, but the pressure is going uphill. So they're moving in opposite directions, changing in opposite ways. So higher temperatures do not increase air pressure. It shows it even more dramatically here, where we do have increasing temperatures, but the pressures are going down. A student claims that dropping air pressure increases the chance of rain. Do these graphs support that claim? So let's see here. Dropping air pressure, here's dropping air pressure, and here's the chance of rain, and it goes from 0 way up here to 75%. So that's an indication that yes, it does work.